So number 12 says, determine the minimum value of the function in terms of a, b, c, and d of this negative a cos bx minus c plus d. So really this question is just to do with y values because we're talking about the minimum value. So we can just say that we could just really just deal with this a and d parts, right? And we take a look at the diagram, it's fairly straightforward. If we start at D and go down A, we end up with our minimum coordinate. So this minimum coordinate here, the y coordinate anyways, is going to be D, and then we're going to go down A. Okay, so that's our solution for this question. Now, we can go a little bit deeper with this question, and we can actually even talk about x values that relate to those y values. So to do that, what I really want to do first is I want to express this in the factored form. And when I do that, I end up getting the horizontal shift of the cosine function. And it's going to start upside down. And that horizontal shift is actually going to relate to this coordinate here. Okay, that c over b is a starting position. If I want to get the x position of that min point, what I can do is I can just add the period. So I'm going to start at c over b. That's my horizontal shift. And I'm going to add the period. In this case, the period is going to be 2 pi divided by the horizontal compression b. And that represents the x coordinate at that point. Okay, and we can also find the x coordinate at the max point. Instead of going the whole period, we can just start the x coordinate. It's going to be start at c over d, and then we're going to add only half a period. Well, that's going to be, instead of 2 pi over b, it's just going to be pi over b, and that will give me the x coordinate at that point. So the question did not ask about the x coordinates, but we can, based on this equation and a, b, c, and d values, find not only the y coordinates, but we can also find the x coordinates as well. And the x coordinates are a little bit more involved, but we can find them.